Hello, in this video I will be covering linear independence. If you are following along with ENGR 205, this is video 13. So with linear independence, this pretty much shows if you have different solutions to a DE with you have a Y1 and a Y2, you can figure out whether or not if they're independent of each other or dependent upon each other using different methods. If they are independent of each other, then there's no interaction with them that would change what they are. But if they are dependent, then it just means that the value of one depends on the other. I mean, it's really not that complex. It's you just kind of solve whether if they're independent. So I'm just going to just go ahead and jump into an example. So for this first one, we have to plug it into this equation I have underlined up here, which is C1 Y1t plus C2 Y2 of t equals 0. If I can get my pen, there we go. And we're going to plug that in for our Y1 and Y2 here. And so the whole goal here is to see whether or not I can solve for C1 or C2 in terms of coefficients that vary from them, meaning that I'm able to combine them with like terms. So C1, Y1 being e to the t, plus C2, Y2, which is e to the negative t, equals 0. Now, C1 and C2 have to be non-zero. I can make this equation true if I made C1 and C2 0, but I need to find a way that I can make C1 this equation true without having any other influence and with as in no other x's or equations, just coefficients in that can be C1 or C2 that are non-zero. So I want to just try to subtract over C2 term. So it equals negative C2 e to the negative t. I try to divide over the e to the t. And I get C1 equals negative C2 e to the negative 2t. Now, since I solve for a coefficient, and I got the other coefficient with a f of x, and so that means that there's no C1 or C2 that is just a number that I can use to make this equation true. So since I could not make the equation true, it means that they are now linearly independent. So therefore, linearly independent. All right, now let's move on to the next example. We're going to do the same thing. We start off with C1 and Y1, which is sine 2t, plus C2, Y2, which is sine t, cosine t, equals 0. So even though it's not obvious, but this will turn out to be a true equation, you just have to make the right trig substitution. So I'm going to change the sine 2t into a 2 sine t cosine t. So this equal, I'm going to subtract over the C2 term, negative C2 sine t cosine t. So now I'm able to cancel out sine t cosine t for both sides. And this implies that I think I lost, so C1. I think I somehow lost C1 here. I don't know what I did. Whoops. I think I it's out. I wrote C1, but it looked like a 4. That's what threw me off. Okay. So anyways, we have 2C1 equal to negative C2. So this is a true equation because we can make C1 equal to -1 and C2 equal to 2, and now it would result in a true equation. It is C1 and C2 have to be some coefficient or any number that makes this equation true. So since true, therefore is linearly dependent. That's about it for this video. If you have any questions, let me know in the comments and give me any criticism you have. Thank you for watching, and good luck on your exams.